Hey, what's up, guys? So we're going to do part 2 today of the Metasploit Unleashed course. So last week or 2 weeks ago, we did the SMB scanning, we did some port scanning utilizing Metasploit, and today we're going to discover idle scanning. So I am in the Offensive Security Metasploit Unleashed course. We're currently going through the information gathering stage, and now we're going to be reading idle scanning. Okay, so it says that Nmap's IPID idle scanning allows us to be a little stealthy, scanning a target while spoofing the IP address of another host on the network. In order for this scan to work, we will need to locate a host that is idle on the network and uses an IPID sequences of either incremental or broken little Indian incremental. Metasploit contains the module scanner IP IPID sec to scan and look for a host that fits the requirements. In the free online Nmap book, you can find out more information about the Nmap idle scanning. And I did open it, and it's right here. So let's kind of go through this really quick and see what information we can gather to just make sense of what idle scanning is and the IPID and all of this good stuff. How to determine whether a TCP port is open. We know that. Idle scan step by step. Okay, so fundamentally an idle scan consists of 3 steps that are repeated for each port. Okay, so it's going to probe the zombie's IPID and record it. It's going to forge a SYN packet from the zombie and send it to the desired port on the target. Depending on the port state, the target's reaction may or may not cause the zombie's IPID to be incremented. Probe the zombie's IPID again. The target port state is then determined by comparing this new IPID with the one recorded in step 1. Okay, so here is a pretty neat example. So it says step 1, we're going to probe the zombie's IPID. So basically the zombie is the machine that is active. It's on the network, but is basically not doing anything. Okay, had to take a quick break and grab a little water, blue carbonated water right here. So it says that the attacker sends a SYN ACK to the zombie. Okay, so it's going to send a SYN ACK package. The zombie, not expecting the SYN ACK, sends back an RST, or a reset packet, disclosing its IPID. The target sends a SYN ACK in response to the SYN. Okay, so first the target is going to send a SYN ACK, or the attacker is going to send a SYN ACK, and it's going to receive an RST with an IPID in the packet. Okay. The second step is that it's going to forge a SYN packet from the zombie. Oh, I see. Okay, so the target is going to send a SYN ACK in response to the SYN that appears to come from the zombie. Okay, so you see our machine is going to send a SYN now from the zombie. So this machine that's receiving the packet is going to respond to the zombie with a SYN ACK. Remember, because the TCP is SYN, SYN ACK, and then ACK, right? So this would be the second step. So then again, the zombie is going to return a reset packet just like it did to us initially with an IPID. So what we want to see is that the IPID increments by 1. And I guess that's going to be, if it does, then we'll be able to use it as a zombie. So now we're going to probe the zombie's IPID again. And we're going to see that it's incremented by 1 again. The zombie's IPID has increased by 2 since step 1, so the port is open. Idle scan of a closed port, idle scan of a filtered port. Okay, we want to find a zombie machine in the network. So it's alive, but it's not active. It's not expecting any packets to be received, and its IPID increments by 1 each time. So I have a few VMs running, and I think you kind of saw them. But let's just look at our network. Okay. So first of all, we're going to do an if config to find out what our IP address is. So this is our IP address in ETH0. I'm going to copy it, and I'm going to do a quick nmap, and I'm going to paste it. I'm going to delete the last 2 numbers. I'm going to put a 0/24. It's telling it to, hey, do an nmap for all addresses within 192.168.100 and 1 and 2 and 3 all the way up to 254. It has found 2 machines, point 11, and all of these ports are open, and point 12, and all of these ports are open. So if you look closely at .11, we have a Microsoft port here. This is like a Java, PostgreSQL. So this one doesn't really tell us anything. This one, we see that 135, which is Microsoft RPC Remote Process. What does RPC stand for again? Let's look it up. Remote Procedure Call. Okay. It's to communicate remotely with the machine. We see that we have NetBIOS. We have this, which is SMB. So this is going to be a Windows machine. So we can do this, right? Since we know. And then we can do attack O. So I'm going to do a sudo su. Okay. And I'm going to do again an mmap. That's what I want to do, right? 11 and 12. Yeah. Okay, so for .11, we have a Linux machine 2.6. For the .12, we have a Microsoft Windows either 7, 2008, 8.1. So what do we have? We have a Windows 7 running, and we have a Metasploitable machine, which is a Linux machine. So yeah, it's pretty accurate. Cool, so we have that. Next thing we're going to do is we're just going to open up Metasploit. Okay, so I'm going to open up a new tab. I'm going to make this a little bigger. MSF console. I'm going to do -Q so it's quiet. So it's loading. So what we're going to do is that we're going to use this Metasploit module to scan and look for a host that fits the requirements. So what we're going to do is we have our Kali machine. I have the Windows machine. I have the Linux machine. I'm going to use this module in Metasploit and see if I can use any of those machines as a zombie machine to spoof it and do a more stealth of a scan. Because basically what we're trying to do is we're going to utilize its IP, so the machine that is going to get the probes is going to log those probes from a machine within the network, or at least that's what it's going to say, but in reality it's coming from an attacker machine. So we're going to say use auxiliary / and we're going to paste what we just copied. We're going to do show options. So our host, so you see here required, this is going to tell us, okay, we need to put all of these parameters in. So we need to put our hosts, our port, snaplen, threads, and timeout. Some of them are already filled, so we need to put our hosts first. So we're going to say set our hosts. So we're going to try, 11 first. I think, let's run it. Let's see. It says I don't have permission. Why is that? Do I need to be running as root? Let's see. Okay, so we're going to use auxiliary. I think we can do info. Yeah, so if you do info within that module, it's going to give you the options as well as a description. And this says that this module will probe the host's IP ID sequences, and it's going to classify them using the same method Nmap uses when it's performing its IP ID idle scan and its OS detection. Nmap's probes are SYN-ACKs, while this modules are SYNs. While this does not change the underlying functionality, it does change the chance of whether or not the probe will be stopped by a firewall. Nmap's idle scan can use hosts whose IP ID sequences are classified as incremental or broken little endian incremental. So we're going to set the R hosts again. And are we going to do... I guess the target port will leave it at 80. And we're just going to set run. So the IP ID sequence class is all zeros. Okay. We're going to do the next one and see if we get the same result. Oh, so you see there is a difference, right? So in the .11, it's all zeros. In the .12s, however, the IP sequence class is incremental. So we have found our zombie. Okay, that's cool. All right, so what's the next step? Okay, so here they're showing you an example where they're doing it for a number of IPs. Some of them are all zeros and some of them are incremental. The ones that are incremental we can use. So it says that judging by the results of our scan, we have a number of potential zombies that we can use to perform idle scanning. We'll try scanning a host using the zombie at 192.168.1.109, which is this one right here, and see if we get the same results we had earlier. All right, so we're going to copy this. So notice that the first ID is the zombie, and then the second one is the target that it's scanning. So we're going to do that ourselves. So first things first, let's get root. Okay, and then we're going to, let's see if we can do okay. So I'm copy pasting the nmap that we saw in the course, which is this, right? So it's basically nmap-pn, which means that do not do a discovery or a ping scan. So don't knock on the door and see if there's anyone there. We don't want to do that. We already know that this host is alive, so we can skip that step. It saves time and it's less noise. Then we're going to do the -si, which is the idle scan. And then the first one is going to be the zombie. So for us, it was the 12, right? Oops. Okay. And then the victim is going to be -11. So it's basically going to send some packets to the .11, and the .11 is going to see those packets come from the .12. And we are the .10. So if we do a quick if config again, this is our IP address. So, but our packets are going to be coming from the .12. So that's why it's so stealthy. Tool. Quitting. Why is that? Oh, I see. It's 100. Let's try it now. Okay, looks like it's working. Idle scan using the zombie at this address. Class incremental. You see, this is cool. And we get the same results. Okay, so this might not look very different to you, or to me, to be quite honest. So let's do something cooler. Let's add a little more. Let's look at what's going on here. So if we open up, actually I can just do it from here. I can just do a little Wireshark. So Wireshark is a network sniffer. So it reads the packages that are going to and fro. So we want ETH0. I need to make this bigger, huh? Okay, I guess I'll zoom in after I started. Okay, much better. But I'm going to stop this right now, and then I'll restart it, okay? So what I want to show is this. Let me do Let's do a new tab. In this new tab, I'm going to go to root again. Okay. So what we're going to do is this. We're going to do a quick mmap scan of .11, because that's going to be our victim both times. And we're going to see what happens. So first we're going to set this up. We're going to rock this. Okay. Boom. We're going to stop this. And we're going to see what happened. TCP.apport 80. Cool. Yeah, this works. Perfect. So that's why it's neat to have something like this. Do you guys have something like this? I just write everything down that I learn on different courses or whatever I'm researching. That way I can reference back to this. I have it in different tabs, etc., like exploitation, enumeration, vulnerability scans, etc. Anywho. Okay, so if we take a look at this, right? We sent a SYN packet from where? Source. This is the source, and this is our IP address, and the destination was the .11. So we sent a SYN packet. We received a SYN-ACK packet back from the target, the .11, to our attacker computer, which is the .10, and then a reset packet. We sent the reset packet because we didn't want to establish a connection. If we did want to establish a connection, we would have sent an ACK package. Okay, so now we're going to do this. Now we're going to use Metasploit, and we're going to see how that goes. Actually, we don't want to use Metasploit. We just want to use our mmap. Okay, so we're going to do our idle scan using the zombie machine, and we're going to scan the .11 machine. So we're going to set up our Wireshark. We're going to hit enter here, and we're going to do our nmap scan. I don't know why it didn't accept it. Let's try it again. Quitting? Why are you quitting? It's not working this time. Are we doing something wrong? So it is incremental. We have... Oh my gosh. I keep doing this, man. It's 100. Oh my gosh. And that's the thing about penetration testing, man. You have to be so detailed oriented, because a lot of times, sometimes things don't work just because of a little error, like a little mistake. You missed a number, you missed a period, or something like that. So you always have to be very cautious. Okay, so we have this, so we're going to run it, but let's restart our Wireshark, our packet capture here, and we're going to hit enter. Okay, it finished, so let's stop this. Let's filter for TCP port 80. Let's do IP. Okay, so here, what I'm just doing is I'm looking for the packets being sent from the .11. Actually, our zombie's the .12, so let's do the .12. There we go. Yeah, I'm trying to. What I was expecting to see here, right, is that the same thing that we're sending the SYN packet, but we're sending it for it. It's recording it as coming from the zombie machine, which is the .12. And I don't see that here. I see it that it's coming from our machine, which is the .10, and it's sending it to the .12, which is the zombie. The zombie sends back to our machine. And that happens several times. And then our target machine, the .11, responds to our zombie machine with the SYN axe. Here we see that our zombie machine sent the SYN packets to the .11 machine. Oh, I see. Okay. We see that this is a retransmission from the 12 to the 11. Maybe because we did the PN. So let me do this again. By the way, look at the warning here. It says that many people use the -pn with idle scan to prevent pings from their true IP. So it looks like that the best practice is that when we use our idle scan, we have to include the -pn just in case, just to prevent that we're not pinging the machine that we're trying to hide from our own IP address and just give it away. The reason that I took it out is to see if it tries to do the discovery. I'm just trying to look for the SYN-ACK reset packet, showing that it's coming from the zombie machine. Okay, so here we do see that we are sending the SYN packet from the zombie machine to the .11, and we're sending other packets to it. And then we'll see that. So if we do IP.source, we will see that it is responding back. The .11 is responding back to the 12. If we do the .10, we'll see that the .10 never talks to the .11. At least we don't want to see that. So you see the .10 talks to the zombie, but never talks to the .11. I was hoping I could find a better example for you, so hopefully this makes sense. But this is what I've got. This is real time, guys. So, and quit without saving. This still works. Good. Wireshark has been giving me some problems lately. Cool. So let's move on. Let's continue with this. Boom. So that is idle scanning. Cool. So yeah, that's idle scanning. So I'm going to include all of the links that we're utilizing so that you can go back and do this exercise on your own and you can read through more thoroughly. And I'm going to leave the links in the description. Okay, so let's move on to the next section. So we're going to be hunting for MS SQL. So utilizing the Metasploit to find vulnerable MS SQL systems. We're going to search and locate MS SQL installations inside the internal network using the UDP footprinting. So when MS SQL installs, it installs either on TCP port 1433 or a randomized dynamic TCP port. If the port is dynamically attributed, querying UDP port 1434 will provide us with information on the server, including the TCP port on which the service is listening. So far we know that, okay, so MS SQL is going to install either on the TCP port 1433 or a randomized TCP port. So to find the randomized TCP port, what we want to do is we're going to query the UDP port 1434, because then this will provide us information with the TCP port on which MS SQL is listening. So let us search and load the MS SQL ping module inside the MSF console. So this module in Metasploit is going to do this for us. So the reason that we're going to do MS SQL is because MS SQL has known vulnerabilities out there. So if the service is running on the server, then we definitely want to find it. We want to scan it and potentially exploit it. But first things first, what is MS SQL? So MS SQL is Microsoft SQL Server, and it's a relational database management system developed by Microsoft. So as a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications. Okay, so it is a relational database management system made by Microsoft. So we're going to start, where are we going? Okay, so let's start MSF console again. Okay, cool. We're going to do search. This is how you search for things in Metasploit. You type search and then the keyword. So in this case, the keyword is going to be MS SQL. So let's do that. So we're going to do search MS SQL. And we're looking for the auxiliary module, and we're looking, I guess, for a scanner. And I think it's ping. Let's check it out. Yeah, it's the MS SQL ping. So there's two ways. You can either copy paste this and then paste it here, or you could just do use, and I think it was 25. Nope. Let's just do then use paste. Okay, so let's do info. It's probably going to tell us the same thing. It's not really going to give us any more information, but it will give us the options. So here again, under the required column, we're going to see that we need to give the R host. So let's set the R host. We're going to start with the .11 one, the Linux machine. And then we're going to leave everything else the same. Okay, so I guess nothing happened. What if we do the .12? This is interesting because it doesn't look like anything is happening. Let's go back to the course. So yeah, here all of this happens. Again, we don't know if we're running MS SQL or not. As far as I know, I'm not running MS SQL. But at least it should tell us that, hey, I scanned it and no, there is no MS SQL, right? So what I'm going to do is I'm going to set our hosts. I'm going to do 192.168.111.12. And now I'm going to do exploit. So now it did scan them, but it's not giving me any results. So let's open up a new tab. And let's test this out, because tools can be wrong. So we know we're looking for port 1433 on the TCP side. And we're going to do port 1433 for both of them. Notice that for the first machine, the .11, it is closed. And it is closed for the second one as well. So this could be the reason why our Metasploit scan is coming on. It's coming up with its hands empty. Let's do a quick UDP. UDP is SU. requires root privileges. Okay. Okay, so we're going to run it again. Let me just copy paste this. And it's closed, so that is it, folks. I guess this is not going to work for us, or it's not that it doesn't work. It does work, but in our case, we do not have MS SQL. But let's go through this, right? Because if you do have it, then you'll hit exploit. All you have to put in is the R hosts. In this case, they put a subnetwork. They hit exploit, and then this is all of the information. So it tells it, hey, for this address, we found that this port is open or running the MS SQL server. This is the version of it. Here's the instance name. It's not clustered. This is the server name. So it gives you quite a bit of information. This is pretty good. So let's read what it says. It says that the first command we issued was to search for any MS SQL plugins. The second set of instructions was the use scanner MS SQL ping, and this will load the scanner module for us. The show options allows us to see that we need to specify our hosts. Okay, we hit run. At this point, you could use the scanner MS SQL login module to brute force the password by passing the module a dictionary file. Okay, so it's basically saying, hey, this module is just to find out, is MS SQL, is that service running? And if it is running, then we want to run an MS SQL login brute force. That way, maybe we can find credentials and log in remotely onto that server. That would be juicy exploit, I guess. So once you successfully guess the password, there's a neat little module for executing the XP command shell stored procedure. Okay, so what this is that it spawns a Windows command shell and it passes it a string for execution, and the output is returned as rows of text. So this XP command shell is going to spawn a Windows command shell from the MS SQL server that we just exploited. So that's pretty awesome. And you can do it by using a Metasploit module, and that Metasploit module is MS SQL exec. So we can look for it here. We can search for MS SQL exec. I'm sorry, not there. Here, search for MS SQL exec. So we'll do info on 0. So this module will execute a Windows command on an MS SQL MSDE instance via the XP command shell or the SPOA create procedure. A valid username and password is required for this module. So we start off with the MS SQL ping to find out if that service is running and on which port. Once we identify that on the specific host and port, then we're going to use the MS SQL login module with Metasploit to brute force it. We're going to give it a couple of dictionary lists, one for the usernames, one for the passwords. Hopefully that's going to come back successful with the username and password. And then we're going to run the MS SQL exec module with that username and password to then get a remote shell on that MS SQL server. And that is how you hack a computer that's running MS SQL, of course. So looking at the output of the net user bacon has password add, we have successfully added a user account named bacon. From there, we could issue net local group administrators bacon add to get a local administrator on the system itself. We have full control over the system at this point. That's pretty neat. Okay, so I hope you enjoyed this video. In the next one, we're going to be scanning services using Metasploit. So I hope you'll join me and we'll do this course together. And by the end of this course, we'll be pretty proficient with the use of Metasploit. So I hope you're enjoying this, and I hope you join me next time. Until then, bye.